Assalamu alaikum kids. Inshallah, in this video we will talk about one of the fundamental quantities that holds the world around us in its place, and that quantity is forces. In the previous video we defined force using the second law of motion, and it says that force is defined as the product of mass and acceleration. It's a vector quantity and measured in units. But we also said that in simple terms force can be defined as a simple push or a pull. There are various types of forces that we'll study in our course. The different types of forces are: number 1, the gravitational force; number 2, the friction; 3, air resistance; and 4, centripetal force. The gravitational force of the earth on any object is known as its weight. At this point, we need to differentiate the terms of normal language use and the terms used in physics. In normal language, we use the terms mass and weight interchangeably. In physics, mass and weight are two separate quantities, where mass is the amount of substance in an object, while weight is its gravitational force. The gravitational force of the earth on any object is known as its weight. At this point, we need to differentiate the terms we normally use and the terms that are used in physics. In normal language, we use the terms mass and weight interchangeably. In physics, mass and weight are two separate quantities, where mass is the amount of substance in an object, while weight is its gravitational force. So weight is a force, it's a gravitational force, hence it's a vector quantity, and its direction is always towards the center of the earth. The formula for weight is W is equals to mg, where W is the weight, m is the mass, and g is a constant that can be defined as two things. Number 1, acceleration due to gravity with units meters per second squared. The value for acceleration due to gravity is 10 meters per second squared. This means that an object in free fall should always accelerate at 10 meters per second squared irrespective of its shape and mass. But of course that's not the case, and we'll learn in future video why objects in free fall do not accelerate at 10 meters per second squared. And number 2 is gravitational field strength, which is the measure of force per unit mass applied on an object by the gravity of a planetary body, in this case, Earth. The units are different from acceleration due to gravity, but the value is exactly the same. Hence, it can be also used in the formula W is equals to mg. The units of gravitational field strength are newtons per kilogram, and the value of g is 10 newtons per kilogram. Another force that we use quite often in our course is friction. Friction is a force that opposes motion. It occurs when two surfaces are in contact with each other. Example, the primary source of friction in a car is the contact area between the tires and the surface of the road. Friction causes loss of energy in the form of heat. That is why your tires become very hot after a burnout. The smoke that you see during a burnout is essentially the tire particles being evaporated due to the extreme heat released when the tires rub against the surface of the road. It's also why when you rub your hands together, you feel warm in winters. Friction depends on various factors. Number 1, the roughness of a surface. Rough surfaces have a higher friction than smooth surfaces. Example, try pushing something on a tiled floor. It's relatively easy to push, but if you push the same object on a carpeted floor, it's very difficult. Number 2, a coating on a surface can increase or decrease the friction of a surface. Walking on a wet floor is considered dangerous because a layer of water on the surface can reduce friction and can cause someone to fall. And we have seen cartoon people falling over banana peels as well. Number 3 is the type of material. Generally, every material has its own set value for friction. Some materials have very high friction, example rubber, while other materials offer lower friction, example glass. This can be observed by spinning a coin on various surfaces. Surfaces with lower friction will allow the coin to spin for a longer period of time, while on surfaces with higher friction, the coin will quickly come to a stop. Like friction, air resistance is also a resistive force, but it only opposes the motion of objects passing through air. Example, a car experiences both friction and air resistance. We can also take the example of an airplane. An airplane is not in contact with any surface, but it still experiences resistive force due to air resistance when it moves through air. Even you can experience air resistance if you put your hand out of a moving vehicle. The backward force that you feel on your hand is the air resistance. An important thing to remember is that air resistance depends on the speed of an object. The greater the speed of an object, the greater its resistance. But friction between surfaces does not depend on the speed of an object. Hence, it can be concluded that an accelerating car experiences a constant force of friction but an increasing force of resistance. At lower speed, friction is greater than air resistance. At higher speed, air resistance is greater than friction. This can be observed by putting your hand out of a car moving at different speeds. At a slower speed, the backward force on your hand would be smaller, while at higher speeds, the backward force on your hand would be much larger. Next is the centripetal force. For an object in constant circular motion, example Earth around the Sun or electrons around protons, two characteristics can be defined. Number one, the speed of the object remains constant. Number two, the direction of the object is continuously changing. Hence, an object in constant circular motion may have constant speed, but a changing velocity. The change in direction occurs due to a constant inward force on the object known as the centripetal force. As we can see in the diagrams, the centripetal force always acts towards the center. For example, a car that's going around a corner, or for an object that is being spun around on a string. An object in uniform circular motion may have constant speed, but due to its continuous change in direction, it can never have constant velocity. So forces can have profound effect on objects. So let's go through them one by one. Number one, force can change the position of an object. Example, you can move a car or a bicycle by applying a force on it. Example, you can either push a bicycle or a car. Number two, force can change the direction in which an object is moving. That's what we essentially do in sports like football or cricket. You change the direction by either kicking the ball or by applying a force using a cricket bat. Number three, force can change the shape of an object. That's the change that occurs when you are crushing something. Like example, you're crushing a can, an aluminum can as shown in the diagram, or when you're stretching a rubber band. Four, force can accelerate or decelerate an object. That's the point of having an engine and brakes in a car. And number five, force can rotate an object. Example, you can rotate a nut bolt around a screw, or just simply opening the door is an example of a rotation because of an applied force. That's it for this video. Inshallah, I'll see you in the next one. Bars out.